Hello, everybody. It's really wonderful to hear from you. I hope that you're having a fantastic day. We're going to be learning some Rust. If you are watching the recording, the first thing that you should do is push the subscribe button. Or if you're watching this on some platform like Twitch or LinkedIn, let's say, or anywhere else that it's syndicated, such as Blue Sky, I guess you would then be clicking like the follow button instead. Hey, my name is Tim, and I am going to be teaching you some Rust. I'm very much looking forward to doing so. Because we're going to be focusing on one of the topics which I find sort of most confusing as a beginner. And I hope that I'm going to be able to demonstrate that with a couple of mental adjustments, we can actually get really productive, extremely fast software that is easy-ish to program. I say easy-ish because if you're having to think about the right way to implement things, there is a bit of there's a bit of that's pushing more work onto you. And so one of the messages actually is going to be, it's not quite your fault. If you've come and my microphone is deciding to like do this, all of a sudden, it's normally very well behaved. Hopefully you can still hear me. I encourage everyone who's watching live to say hello in the chat. You'll see I've enabled this, toggled this thing, so hopefully there will be over on this side. Hopefully you'll see yourself kind of bubbling up the top. Really excited to get some participation going and some discussion. Aha! Okay, there is. So by the way, the t-shirt is hanging there. And I thought it was kind of appropriate for today. We're going to be looking at asynchronous Rust and so why is this so hard? And by this, I'm sort of why is async Rust so hard? And here are a couple of reasons. The first one for me is that asynchronicity is that sort of async does things differently. It's actually a different way of programming, but we have our old brain switched on. We think of programs as though they're executing from top to bottom, but if we have, say, a conditional with an if, it kind of goes out to the side perhaps, and we kind of split the logical progression of the program steps. We might have loops, so we can kind of go back up and then come around. But ultimately, asynchronicity is different. It actually allows the program flow to be much jumpier. And when we come to async, we don't quite get that. We don't really have that at the top of our mind. Or at least we can see that there are some async keywords. For example, if I wanted an async function, let's say I would do some work. And then in here, I've got, I've got something that I actually want to produce, but we'll just silence some warnings there. The work function that I've defined behaves differently. Once you call it, in our case, we're going to be calling it in main. This will complain a little bit, but that's okay. We don't actually get a value. Instead, we get this future thing. So my code editor has just added impl future, which stands in for some type, which we don't know the name of. In fact, we can't even name it. But we know that it implements the future trait. And when that at some time in the future, will produce a output. And that output is the unit type. So if I just change this, for example, to return back an integer, you can see that the output has also changed down on line 11 to also returning an integer. In our case, now that switch, you can kind of sort of get, you kind of like, I figured that out. Until you start doing things like this. So we've got another, we've got a on line 7 here. I've added a print line macro. That print line is actually going to be, that print line macro is actually going to block every single piece of work that's happening at exactly the same time until the print is finished. I'm just going to pause there because there's an important question that has popped up. And it's, are you going to be comparing multiple executors, such as Tokio, Embassy, potentially there's a couple of older, there's a couple of others as well. Tokio is used most heavily in web services. Embassy is used in embedded devices. There are a couple of other competitors such as async stud or async standard, and there's actually one, a couple of others bubbling around. One also called Small, which is kind of cute. The bulk of what I'm going to say here applies to every executor, except that some of the specifics are different, and I'll kind of call that out. The fundamentals are essentially the same problem. The fundamental problem is that we accidentally add blocking IO or blocking functions into our code. And because Rust is very heavy on dependencies, if any of the dependencies or any of your dependencies have anything that blocks, your performance of your entire application is kind of slows down until that thing is finished. And there are some quite, and there are some relatively unobvious places where that happens. And the easiest one to describe is with Hello World. And there is, so I'm just going to actually say, I'm just going to call this, we'll call this, say, issue print. For reasons that I'll explain later, I'll also add essentially as a to-do list item to myself, files. This is, and I've got another one, which is locks. And I'm just going to give a note to myself here to write mutex. In a case, standard versus Tokio. And the, and we'll find that opening files, standard FS file, or it might be, or is it standard IO? I always get those two kind of muddled up. Using the two file types is different and requires some revision on documentation. Okay, and we've got a follow-on question. What about pin and unpin? I'm not going to touch that particular topic in this tutorial. If we really want to deep dive at memory layout and what's going on in the moment, that will really detract from some of these things that are really surface level. We can talk about that in a future tutorial. Come and nag me online and just say, Tim, when are you finally going to discuss pin and what the hell that is? And what is unpin? Okay, and welcome, Josh, and welcome, Script Junk. Welcome, everybody, to the stream. It is really wonderful to see everybody. We are talking about async Rust, and I've said that, so why is async Rust so hard? And I've started with this idea, async does things differently. But I think there's a secondary point, which is that people arrive at Rust. Oh, actually, it's like 1. I'll add an extra 1.1 and 1.2. Rust implementation of async is also different. Particularly, it's different from Python and JavaScript, or the JavaScript, TypeScript. I'm just going to say those are the same language. Sorry. And from Python, and that's a problem because people are arriving at Rust, so they're arriving to Rust from Python and JavaScript and TypeScript, and they are trying to build stuff. You arrive at Rust and it's like, the first thing I want to do, and this is actually, and the first thing they want to do is write a web API. So it's actually not so important that they're from some other language community. It's more that the first thing that people try to implement is writing a web API. It's essentially, it's kind of the hello world of Rust. That becomes a problem because you get thrown in the deep end of all of these complexities without the knowledge of how to actually hold things properly. And so, and there's a subtle point of this, and that 2.2, all of Rust's web frameworks seem to require async. So there's not like an easy mode where you can sort of get started just with synchronous Rust. You have to use async. So when you start, you know the least, but you have to know the most in order to get things really, really fast. And so I'm curious as to whether or not if anyone disagrees with any of these kind of like statements. If you do disagree, I'm very curious. I'm really, please do add comments in the chat, because it's very, very valuable to me to kind of continue to refine my own thinking. I'll just continue to add notes here. Right, let's talk about this print line thing. So we've got this problem of accidental blocking I/O. It doesn't look like it, but when you add a print line macro, Rust, and let's see if I can pull in the definition. What it will, so I've gone with Rust Analyzer and dug into the internals of the standard library. We then call this internal crate IO, this underscore print thing. I wonder if I can find that. I might be able to pull it up in here, but I'm actually tempted not to. But what I know goes on is it goes and actually adds a lock. The other thing that it does, oh look, it's sort of explaining here. So the documentation also has a little bit of a warning that it will lock the standard output each call. And so if you want to do things, there's a way out. And the way out is to manually lock and unlock by accessing the like this standard IO. This will be causing people kind of a lot of confusion. We'll bring the module use standard IO, standard out. Actually, it's standard out that we really care about. And we kind of need this standard out object. It's a function that returns this standard out thing, which includes you can see we've got reentrant block in there, and notably it implements write. So we also need to bring the write trait in, and it turns out that in order to use this particular type in in an async context, we're going to need to make things even more complicated. We need to replace this print line macro with calls to, we need to treat it like a writer. So we need to say, we could either just use the write macro itself, and then we can do hello world. At this point, though, we're kind of holding standard out the wrong way, because you might remember that we kind of can't, we need a lock. We actually need to acquire the lock. And now this function is actually holding it. And now we are closer to what we would require if we were non-blocking. This is actually still using blocking IO, and it's very grumpy with me because I'm using the wrong type. So I'm just going to return a number while we get started. And this is a macro, not a function. This needs to be mutable. Not the first one, but okay. And I'll move that out of the way so we can do, we are kind of clearer. And let's just double check the documentation for the lock. And we also could flush. So the idea here is that one of the things that we could do is we could also write flush. But I'm curious, I'm going to ask in the question, in the comments, for anyone's ideas on why you don't necessarily need to flush the buffer or even ever call unlock in Rust. This is one of the very significant, really important things about Rust in general that makes it an extremely good language. Very, very hard to misuse. Generally, Rust will not provide a close method on files. It doesn't need a close method on network sockets, and it doesn't need a release method on locks. And that's because the ownership model of Rust will automatically release the lock when the variable that is holding the lock is at the end of its scope, or more formally, is at the end of its lifetime. And no longer, and then it will, in its destructor or in the implementation of its drop trait, if you want to use the Rust-specific terminology, will release the lock itself, sort of under the hood. So you don't actually ever need to worry that you will forget to release it. It makes it much harder to introduce deadlocks. But this isn't quite enough. This is not enough for us to do, to use, in our case, we're talking about Tokio here. Features full, by the way, isn't particularly important. It's just handy. So I've just added this extra line in my code. I've asked Cargo to do so itself. And so now my project manifest, my cargo.toml file, I now have Tokio available to me. If you're using Embassy, you'll need to check its own documentation. But in practice, what these executive frameworks need to do is provide their own versions of traits and types. So you'll see here that there's actually an async write trait that we need to bring into local scope. Well, strictly speaking, we don't need to, but that's okay. Our job here is to remove the standard library's implementation of standard out, or with its locking call, with something that is non-blocking, or otherwise known as asynchronous. And so just remove that, it's no longer useful. And Tokio, IO, and I need standard out. Voila. Now this looks on the surface like I've got two things called standard out. The naming, so this first on line 20, it's from Tokio, and then I immediately shadow or replace the variable with one from the standard library. But don't be confused. The intent here is not to the intent here is not to confuse you, but just to demonstrate that the Tokio method, sorry, the Tokio types no longer has a lock, which is good because we don't want to block the thread. We really want to stay asynchronous. Now, write is not going to work now. So this this macro, which that I used, is provided by the standard library. It's not provided by Tokio. So we now need to kind of get rid of that. And let's have a look at what we have available to us. We have a write method. So we could just call this is a little bit clunky. Because I need to call as bytes on the buffer, sorry, on the string slice, but actually I can also prefix the string literal with a B, and that will also turn it to the intended type, which is a byte slice. Woo! Right. So I've now done so-called the right thing. At least I'm closer to it. I've got a bunch of, I hope, warnings. Yeah, these are unused warnings. It's saying, gosh, Tim, you're really being very, very saying, the compiler's saying, mate, you don't need all of these. Leave them alone. And the but I've actually got a more. I'm going to bring these down just so that we can separate this out. So this is the problem code. The standard library blocks, and the so-called correct code is non-blocking. If you are not sure what the term blocking versus non-blocking means, or synchronous versus asynchronous, that's actually okay. But do remember that it is something that you should figure out. I don't mean that in the mean it's like go and learn harder. What I mean is you can continue to be productive but you should remember that there's a gap in your knowledge. So and over time, that gap will be filled in as you gain experience. I'm happy to talk things through, but there's one thing that I think is actually subtly more important, which is that this is a lot of work. The frameworks and the language and people's mental models are all not really meshing together very well. That's not your fault as a programmer who's learning this stuff. It's genuinely not. It's genuinely complicated. It's complex and difficult. Asynchronicity came to Rust late. It was added on to the language. In my last tutorial, sorry, my last live stream, I spent a long time explaining what the async and await keywords actually mean. And it turns out they mean a lot less. They're just then they mean a lot less than you think. And so if you're confused about what this async keyword actually is doing, and you want to remove the magic from that, just go check out the last video in my catalog. But in saying that, I think it's the one of the things that's really challenging is that I now need to remember that I need to use the correct type from the correct framework to do the correct thing. If you are in if you're using a different executor, let's say Embassy or Small, you're going to need to read their documentation on how to print to standard out or write to any file descriptor. The same is going to happen for the next two sections. One is that there is some documentation in oh gosh, sorry that the text is so small. We're going to be looking at files. And one of the things that I want to, I'm just going to change the color, I think, which is probably a silly thing to do. And, oh no, this is fine. This is absolutely fine. I shouldn't be distracted. The point that I want to make with files is that there is some documentation that's kind of relatively hard to see that you need to do more stuff. Firstly, we need to bring in the right type, that is the file system, so the file type from the file system module of Tokio, not from standard. And you need an extra trait. We've got this extension trait, which provides a write all method, and a bunch of other things. And the documentation is that the reason why this is a problem is I saw a comment on Reddit. I wonder if I can bring it up. Sort of talking about Tokio being slow, which actually inspired this whole discussion actually. 7 years ago is not particularly useful. And now I can't find it, so that's cool. Anyway, so I'm getting distracted. You are not supposed to use the standard file type for Tokio. If you do, you'll get into problems. Let's bring out Tokio.rs and learn and IO. We talk about what files mean, and the problem becomes that we need specialist types for all of these, and traits for doing things that are supposed to be easy. And it's really tricky because you as a learner need to learn a lot of extra stuff just to get some really simple things done. Sorry if I'm saying the same thing 14 times. I don't actually mean to. The reason why I'm doing this is partially because I am trying to find the kind of warning that says, do not use the standard IOs. Do not use standard IO, the file type, but I can't see it as brightly as I would like. Okay, that's where I just started. And sorry for jumping between dark and light. The last thing is similar but different, and that is locks. So let's look at mutex. One of the things that I found most complicated and most confusing about Tokio when I was starting was that you're like, oh, okay, so the rule was I should use the Tokio type instead of the standard type. So actually, we can add that to our list of things. So like generally, so we just say correct code uses Tokio FS and Tokio IO, or Tokio, depending on how you pronounced Tokyo, I suppose. These two modules but down here, we've got this kind of weird, clumsy situation. And oh gosh, pushing the wrong button now. And the thing that I want to get to is over here. It turns out that for locks, the situation is much more complicated because you're supposed to combine types from the standard library and from Tokio together. So you kind of now need to not just worry about if it's like arc inside a mutex or is it a mutex inside an arc, but also which mutex, because there are, and there is also some differences around how the thing actually works. And you can see that where the code is that, and one of the, so this is the line that stuck out. I said that the thing that I found hardest about Tokio was this. It's this one specific line, and I'm just going to make it quite big and quite obvious, is that it is okay and often preferred to use the ordinary mutex from the standard library in asynchronous code. And I read that and I thought, okay, like this sucks, because now I can kind of accept that if I'm in Tokio, I replace all of the file IO and all of the rest of the IO with Tokio types. So I no longer use standard. But now that I'm using these concurrency primitives, like these locking things, I now need to use the standard arc with Tokio's mutex and then discover, oh, wait, but no, you can actually just use the standard library's locks. Okay. And this kind of, I find particularly tricky. Like, it's just a very unfortunate set of, an unfortunate state of affairs that you as a beginner kind of walk into like a labyrinth of decisions. And then you get other things of like, well, you know, there are very specific reasons as to why you would use an asynchronous mutex, and that relates to protecting IO resources. And so, by the way, there are actually plenty of times when you do need to use Tokio's mutex rather than the standard mutex. And all of this complexity makes it really, really challenging. And so I think it's okay for you to remember that there's a lot to learn, and you don't necessarily need to learn it all to get started. Because, and I mean this in the nicest possible way, your code isn't going to need the level of performance that Tokio can offer. And like Tokio is going to be able to run hundreds of thousands, potentially millions of tasks at the same time on a relatively lightweight, mediocre server. It doesn't require a huge amount of like your code that's doing 50 to 500 things per second is going to have enough time to make mistakes. Where was I going to go next? I was going to make myself bigger and then check if there are any questions. So now is the time for you to ask any questions. And I think that I should... Oh, so there was a good point here, maybe that the module docs show it better because I was trying to fumble my way through all of this documentation. So sorry while I had to figure that out, and hopefully you're still with me. And I think we mentioned the documentation on the website and its traits. And then the question is, well, what about read-write lock? Okay, let's go figure that out. I can do that. I actually know how to do that because I have a computer and I can look on the web. By the way, I'm very millennial, so WB, I'm just assuming means what about. So I have no idea what that actually means. So if I've made a mistake, and that definitely feels like when I started on the internet, we didn't say WB. Maybe I'm wrong. So if I am wrong, let me know. And let's go. Look, I need to change the screen across. Ta-da! Read W log. And so the difference just generally between a mutex, which stands for mutually exclusive lock, and an RW lock, which stands for read-write lock, is that is that a mutex provides exclusive access for one reader or writer. There's no distinction. Mutex does not distinguish between readers and writers. However, RW lock allows multiple readers unless that there is one writer. So it upholds it upholds Rust's rules that you can have multiple read accesses, but only one write access. So let's go check this. And we have we've got a note here to say that Tokio has been opinionated on how it offers priority for access, and that Tokio's locks behave differently. Tokio's read-write lock behaves differently. It prefers to give something that wants write access. It kind of puts the part of the code that is asking for write access to the start of the queue. Whereas using the standard library, you're waiting for the operating system to make that decision. However, there's nothing further about whether or not you should use the standard libraries read or write in like a general case. If we do potentially have the other way around though. So if you have the problem where you require a lock to be shared across synchronous code and asynchronous code, so you're essentially passing this thing around outside of Tokio, you do have the ability to call this blocking read and its sibling blocking write, which means that the Tokio's read-write lock potentially is more general purpose, as long as you also remember that you kind of also need to call the right thing from outside of Tokio if you were to share it outside. But that feels a little bit like we have hit the end, except potentially to say that it is hard to know quite how to hold some of these types, and it is difficult to know exactly what's right. For example, the underscore owned methods provide a mechanism that gives you it provides exclusive write access and so forth, and has this other property where things will wait until it's finished. And so the exact semantics that you are getting are so you need to check that the semantics that you're getting are the semantics that you intend. And that goes all the way back to the start of this discussion about how the reason why async Rust is really hard is that async is itself different than synchronous code, but Rust's implementation is different, and people arrive at Rust without an understanding of both of those because they want to write web APIs, and most web frameworks, in fact, almost all of them, require asynchronous code to start with, which typically means Tokio, and then you're kind of down a very long path to figure out exactly how to get started, which is almost the wrong way around. I am going to pump my stuff. I should remember that I've got to. So first of all, if you're still watching this, do like follow and subscribe and things. It's really helpful. Like the thing. It feeds the algorithm. It really does. And it means that if you find this particular style of tutorial or discussion useful, please watch my other stuff, share it with friends, and so forth. That's very, very helpful. Lastly, if you, or not necessarily lastly, I've got like Discord servers and like social media channels and things. And so if this is, if that's at all useful to you, please feel free to follow me around on LinkedIn even. I'm there too. But wait, there's one more thing, and this one almost is a relatively genuine ad. I want to encourage as many people as I can to come to New Zealand in August, because I'm hosting a conference and we have some ridiculously amazing speakers. And Tom has just confirmed that he is going to be speaking about designing superconducting magnets for fusion power. We're going to a fusion reactor. I have Sophia Turner, who was involved in the TypeScript and Rust and has multiple, like created the Rye scripting language, for example, and multiple others. Matthias is from Germany. There's a whole bunch. Ohun is the Ratatouille guy. Adam Harvey works at the Rust Foundation. And in fact, there's more. There's quite a few more speakers. We're building a linker. David Lattimore is writing the wild linker. Jack over here on the right is talking about creating basically, he's got this kind of really interesting VJing setup, which we're going to try and do a thing for in the evening. And Jonas is talking about like what actually happens once you hit panic. And there's a whole bunch of other interesting things. And look, by the way, Steve is coming. Steve is coming from Austin. And I am just so pumped. I'm really, really, really excited. And I want to share that excitement with you. And so I'm going to create a discount code of like, let's say 15% of like, and it's going to be Tim clicks. And if you, so like click through, and where do we, oh, by the way, there's I'll allow you to trigger the Easter egg yourself. But if you click attend, I should have a bigger button, which is just register. Oh, there's a register now button on the thing. It will take you to a new one. And if you buy a ticket, and there's actually, I took off in the show notes for this thing, there'll be a link. It's not there yet, but there will be. And it will have a Tim Clicks code that you can use for a 15% discount off the sticker price. And I will be absolutely thrilled to welcome you here. Okay, I'm going to stop talking about RustForge, even though I want to continue to talk about it a lot. So yeah. Oh, so this is the other one. Let's look up Discord to Clicks Lounge. So the other thing to if you are interested in following me online, like hanging out, do hunt for this thing, Clicks Lounge. Oh God, it's opened up my stream. Oh look, there's the stream right there. And there's about 1,000 of us hanging out, learning Rust. So with that, I'm going to I'm going to hang up, actually. It's been a wonderful stream. I am really thrilled to welcome everyone to Rust. If you have more questions and want to learn more about the particular topics and you've got things that are difficult, please let me know and I can log them and create future videos. Otherwise, I will see you later. Have a very good week wherever you are. I wish you a really productive, happy, healthy week. And my name is Tim Clicks. I'm on the planet to build a better planet. Thank you.